Students, today we'll be discussing some important topics based on the gravitational force, gravitational potential energy, escape velocity and orbital velocity. First of all, we consider the concept. We have to show that moon would escape forever from its orbit if its velocity is increased by 42%. You consider this. This is Earth. This is the orbit of the moon. This is the distance r. The moon is moving like this way. You know that this is circular motion and centripetal force m naught square r, it is equal to g m upon r square. Capital M is the mass of Earth, small m is the mass of moon, and r is the radius. So this m goes off, 1 r goes. So V naught, orbital velocity of the moon, it is equal to g m by r under the root. Again you can write it, Gm is equal to z r square upon r. 1 r gets cancelled and V naught is equal to g r under the root. Now escape velocity, the formula for escape velocity is, that is twice g r. This must be the velocity, escape velocity. Now we have to see the percentage increase in velocity. So this is VE minus V naught upon V naught into 100. So this comes out to be root 2 GR minus GR under the root upon GR multiplied by the 100. So it is very easy. ZR root, it is common, root 2 minus 1 upon root GR. This gets cancelled and you are left with 1.414 minus 1 multiplied by 100. This is equal to 0.414 multiplied by 100 and you get it approximately equal to 42%. So for the moon to escape from this orbit, the velocity must be increased by 42%. Now the next concept is, while there is no atmosphere on the moon, we know that the size of the moon and the mass of the moon is comparatively smaller than Earth. Therefore, gravitational pull, gravitational force is also very less in comparison to Earth. Gravity is very small. So, due to this small value of gravity, escape velocity comes out to be very small. That is, at the moon surface. At the moon's surface, the escape velocity is approximately of the order of 2.3 kilometer per second. Now, in the atmosphere of the moon, the RMS speed of the molecules of the atmosphere is greater than, that is VRMS. ये VRMS क्या है? Root mean square speed of the molecules of the gases in the atmosphere of the moon. That is greater than 2.3 kilometer per second. Therefore, the molecules escape to the space and hence there is no any atmosphere on the moon. On the other hand, you see that in case of Jupiter, the escape velocity is, that is 60 kilometer per second. But the VRMS, velocity of the molecules of the gases in the atmosphere of the Jupiter, that is small in comparison to 60 kilometer per second. Therefore, the Jupiter has thick atmosphere. That is the region. Now we come to another concept, the concept of black hole. What is black hole? I will give you simple description, simple and short description. In interstellar space, we have the clouds of the gases. When the mass of the interstellar space becomes greater than a specific value, then those gases, there's cloud of the mass starts collapsing towards the common center under its own gravitational field. During the collapsing of the gases, what happens? The central part becomes very hot, pressure becomes very high, and thermonuclear reactions start taking place. When thermonuclear reactions are there at the center of the star, then mass starts converting into energy according to the formula E is equal to mc square. As the time goes on, as the time passes, the mass of the star that starts decreasing, and when a certain stage comes, what happens? The star, when it is to be end, near the end, the outermost part of the star that starts increasing, and that is known as the phase red giant. And then happens the explosion supernova. There are different conditions for the star to become red giant or the supernova explosion. So during the supernova explosion, what happens? The outermost material is thrown in the interstellar space with very high energy, and the central part left, that starts further collapsing. What happens? The central part, in the central part of the star, during this process, the density becomes infinitely high and the volume diminishes approximately equal to 0. That is the black hole. So the density is so much high that even the speed of light cannot escape. It is very difficult, and that is why these are known as the black holes. These black holes are varying in size from few centimeters to kilometers and so on. So the case is, the black hole, for a black hole we have a mass. The mass of the black hole is 9 times the mass of the earth. So what shall be the condition for this mass to be a black hole? You know that escape velocity VE, it is equal to twice Gm upon r under the root, where r is the radius. Just we have to find out the condition for the radius. So according to relativity, this speed 2Gm upon r, that must be less than or equal to speed of light. Speed of light is the maximum speed attained by an object. No object can move faster than speed of the light. So if I equate this, that is C is equal to 2Gm upon r under the root, squaring both sides, what we get? C square is equal to twice Gm upon r. Cross multiplying, we have to calculate r. R is equal to 2Gm upon C square. You can multiply it by 9 because the mass is given as 9 times. So this is the formula, and mass is 9 times. Okay, then you can write it 9 here also. So the R comes out to be equal to, that is 2 into 6.67 into 10 to power minus 11. And of course the mass of Earth, that is 6.24 into 10 to power 24 kg. 24 kg multiplied by the 9. And of course the speed of light 3 into 10 to power 8 meter per second. Square कर दीजिएगा. If you solve it, you will get that is 8 centimeter. So the radius will be very small of such a black hole. So this is the condition. If the mass is 9 times the mass of the Earth, then after the process, it will be reduced to a radius of 8 centimeter. This is how the black hole reduces such size. The concept of black hole is very important in theory of relativity. You will be taught this topic in the further higher level studies. Okay, thank you.